All right, so far during this unit, we've been talking about the theory of evolution, which just states that all species come from a pre-existing species. And in order for a theory to be accepted by the scientific community, that theory has to be well supported by data and evidence. So then for the past week or so, we've been looking at the different pieces of evidence we have to support the theory of evolution. There are 9 total pieces, so today we're going to cover that 9th and final piece of evidence, and that is evolution can be seen. Okay, so we can see this happen. We see it happen with bacteria and viruses, so organisms that reproduce quickly, and there's a lot of them, so big populations. And so when we look at populations of bacteria, we can see that they're evolving to become more resistant to our drugs, which means drugs that used to work and kill bacteria are no longer effective. And how many of you have heard of like the saying like antibiotic resistance?
How do we turn this in?
Have you heard of antibiotic resistance before? Or anything called like MRSA or like TB resistance? Okay, if not, today is the day. Okay, take a look at this diagram up here. So there's nothing to write down, but I want you to look at the pictures so I can explain how does bacteria evolve to become resistant to antibiotics. Okay. And when I say resistant to antibiotics, it means antibiotics are no longer going to be effective in killing that bacteria. Okay. So if you take a look here, the first diagram, this is a sample of bacteria. The blue bacteria are just like your normal, regular bacteria. The orange is going to be resistant. So I'm going to use an example of pink eye to kind of help build the story here. How many of you have had the luxury of having pink eye? At some point, right? Most of us, right? So if you have pink eye, you end up, if you have bacterial pink eye, you end up with bacteria in your eye, right? So let's pretend, for this example, you have pink eye, okay? So you have a whole bunch of just normal bacteria, but you have one that is resistant to medicine. So first of all, how does this happen? So bacteria reproduce asexually, which means think of it as like they clone themselves, meaning all of the DNA in one bacteria gets completely transferred to the offspring, whereas in humans, right, if humans reproduce sexually, the offspring is half the mom, half the dad, right? But in bacteria, you are just 100% the parent copy. Meaning, if you have a normal parent bacteria, their offspring has to be normal. So how do you get a resistant strain? You have to have a mutation. Okay, so even though that's not bolded, maybe add that to your notes. That mutations are what's going to cause resistant strains of bacteria to arise. So if you have bacterial pink eye, it's probably not going to go away on its own. And you have red eyes and they're goopy and you probably don't want to live your life like that. So who do you go see?
Doctor.
The doctor, right? And the doctor is going to give you antibiotic eye drops. Okay. So you start using the antibiotic eye drops. How fast till like the goop starts to clear up out of your eye?
Like a long time.
Okay. Some people it's super fast, others takes a while. So go ahead and look at this second picture. So once you add antibiotics, and they're going to start killing the bacteria. And do you think they're going to start killing the normal bacteria or the strong bacteria?
Normal.
Okay, the normal, right? The normal ones are going to get killed first. So if you look here, once we start adding antibiotics, most of your normal bacteria are going to die. Now it's going to take time to kill them all. So you might have some regular bacteria left behind, and it's not going to be able to kill your resistant bacteria. So then if whatever's left behind has time to multiply, right? It has time to replicate. So if you have regular bacteria left behind, it can reproduce, okay? It can divide and multiply. And you can get more regular bacteria. If your resistant strain is left behind, can it reproduce and multiply? Yeah. So then you start getting the sample here where I have a lot more resistant bacteria, okay? I'm still taking my antibiotics so I can kill the regular bacteria. With enough time, I'll be able to kill the regular bacteria, but my antibiotic's never going to be able to kill that resistant strain. So you can see here that the population of my bacteria, it's changed or it's evolved over time. So this is an example of how evolution happens. And so we use pink eye as an example. Another one is, this happens with strep throat. Who's had strep throat before?
I've had it so many times.
So many times. Now, have you ever had it so many times, like in the same month?
Yes.
Okay, so if you've ever had it, how many times have you had it in the same month?
It's like this one.
Okay, and each time, did the doctor switch up your medicine each time?
Yeah.
Okay, so if you ended up having a resistant strain of the strep bacteria. So what happens is you get left behind with these. So then the doctor has to go back and try a new antibiotic and hope that that antibiotic will kill the strain. And then if it came back again, it means that it must have been resistant. So you have to go back and try another antibiotic. Okay. Now, is it good just to be taking all sorts of antibiotics? Okay. It's not good. It's going to kill your normal flora bacteria, like your good bacteria. Also, depending on the antibiotic, it can also just kill your normal cells. Okay. So, do you ever want to be the host of resistant bacteria? No. Okay, no, right? Put that on like your not to-do list in life, right? You do not want to be a host of this. So, how do you avoid, or how do you try to avoid getting a resistant strain of bacteria in you? How do you avoid getting resistant bacteria in you? Take all of your antibiotics. Okay, so let me give you an example of what not to do.
Only if necessary.
Well, follow your doctor's orders. So let me give you an example.
I got bronchitis and I took like 3 of the pills that they gave me and I just didn't take anymore.
And then you felt good, right? And you just moved on with your life, right?
Yeah.
Okay, so let me give you an example of what not to do. I'm going to go back to the pink eye example. So a couple years ago when my kids were younger, they used to get pink eye all the time. And little kids, they touch their eyes and then they touch everyone's eyes. So who else do you think got pink eye all the time? Me and my husband. And so our kids would get eye drops and like he would just steal like a few of my daughter's eye drops, enough just to like clear up his eyes. However, if you just killed most of them, so like you don't see symptoms, could you still be leaving bacteria there? Okay. If you leave the bacteria there, you open the door for them to reproduce and multiply. You open the door for a mutation to occur and for it to become resistant. Luckily for him, mutations never happened and he didn't have any resistant bacteria. But by not finishing your course of antibiotics, you definitely leave the door open for having any sort of resistant strains. Same thing is true for strep throat or bronchitis. How many of you have just had to take an antibiotic just when you were sick at some point in time? Right. Usually, you start to feel better after a day or two, right? So it's tempting to stop taking that antibiotic, but the doctor usually tells you take it anywhere from like 7 to 14 days. You want to keep on taking it for the whole 7 to 14 days, however long you're supposed to, because do you want the possibility of just the resistant strain to be left over in your body? No way. Okay, we see evolution in viruses as well as bacteria. So take a look at the picture up here. So here's a picture. I'm showing evolution of different types of viruses. So the picture on the left is a more virulent virus, meaning it's going to make you more sick. So think about when you've ever been like super, super sick. You stay in bed. You're not going to go to school. You're probably not going to see your friends for a few days. So are you going to have a chance to spread your germs to other people? Okay. Not really, right? When you're super sick. Okay. So when we see a lot of viruses, the ones that make people more sick, we see less mutations coming from those because they usually don't get the opportunity to jump from host to host. But think about a less virulent virus, like the common cold. How many of you live your life like normal if you have a cold? You go to school, you see your friends. If you're like a sport or an activity, you keep doing your sport or activity. So whenever you have a less severe virus, there's much more opportunity for that virus to jump from host to host. And then when it can jump from host to host, there's always the potential for a mutation. So we see lots of mutations within like the common cold, right? How many different cold strains are there out there? A bunch, right? How many colds do you get in a winter? Think pre-face mask year. Like before we all like wore face masks, how many colds would you usually get?
I never really got colds.
Really?
Yeah. I'm so different.
There. You're right there on average. I think average is like 5 or 6 a year. Okay, so we see lots of mutations, lots of evolution on those less virulent strains. Let's talk about just the flu. How often is it recommended that you get a flu shot? Okay, say that louder. Once a year. That's because the flu virus, it evolves, right? There's lots of mutations and it evolves quickly, which is why we recommend a yearly flu shot. What about COVID? How many of you are hearing in the news or reading about different strands of COVID?
Yeah, apparently there's one in like France that like is getting younger kids sick.
Oh gosh, I haven't read about that one.
Older people.
I've read about like the UK variant where it's just more contagious. So we see evolution happening like at this moment with COVID. So when we see different strands, that's evolution, right? We're seeing a change in that population.